Good morning, one and all. Today, we are going to continue the session which was left over in the previous class. In the previous class, we have discussed about production function. What is meant for production? Generally, I am taking a small brief about this one, that the conversion of the inputs into outputs by means of following a systematical approach by using the available all resources is considered as production function. And production function means the relationship between the input factors and output is considered as production function. Okay. Now, coming to the part of Cobb Douglas production function. This is very, very important from your examinations point of view. Definitely you should have to okay, learn the concept of Cobb Douglas production function in an effective manner in order to understand the total production function. So that production function means production function is invented by Junt Wicksell and kuda antaru. So Wicksell and first tested by Cobb and PH Douglas in 1928. Means the production function was first invented by Junt Wicksell. Okay, and first tested by means okay, one person can have the scope of inventing one concept, and some other person, if going to test in the real market, then it is considered as tested by some other person. Here, Cobb Douglas, these are two people. They are two people, not a single person. Tested in 1928, means nearby before 92 years exactly. So that 98 years. This famous statistical production function is known as Cobb-Douglas production function. Okay, it was applied initially in American manufacturing industry. Means whenever this production function was invented by John Wicksell, this production function was first tested by Cobb-Douglas in American manufacturing industry. Cobb-Douglas production function takes the following mathematical form. Y is A into K power alpha into L power 1 minus alpha. Okay, take a small fraction of second gap. Y equals to A power A into K power alpha and into L power 1 minus alpha, where Y equals to output and K is capital and L is labor, and A, okay, and alpha are positive constant. Means here A is constant. Here he is taking the two variables. One is capital, second one is labor. If you are going to increase the capital by means of this formula, this mathematical representation I am explaining. By means of, if you are increasing the capital, automatically, okay, there might be decrease in the labor quantity. If you are increasing the capital, you can have the scope of increasing the technology. You can adopt new technologies, new updated machineries, okay, in order to minimize the labor. If you are increasing the labor, automatically such kind of expenditures needed or required for purchasing the technology can be reduced. So K and L here are inversely proportional to each other. If K increases, L decreases. If K increases, L decreases, and L increases and K decreases. So here, if you talk in the sense of probability, if alpha value is 0.5, then L power 1 minus 0.5 equals to L power 0.5 and K power 0.5. It's here 50% of capital and 50% of labor. If 75% of capital is used, automatically labor will be decreased to 25%. If 90% of labor is used, 10% of capital should be used. Such kind of relation exists between the labor and capital in Cobb-Douglas production function. Next, Cobb-Douglas production function assumptions. It assumes that output is the function of two factors, that is capital and labor. Means here there is no third output concept, okay, third input concept. Here only output is dependent on two aspects, two input factors, not for the third input factor. Okay, so here what I'm saying, this function is only applicable, Cobb-Douglas production function is only applicable whenever you are going to use only two input factors, that is labor and capital. If you are using the third input factor, then this law is not applicable. There are constant returns to scale. Constant returns to scale means study returns to scale means study inflows, study okay incomes, study okay production, and study technology. Such kind of things are considered as constant returns to scale. And next one is all inputs are homogeneous. Homogeneous means okay proportional to each other. Homogeneous means for example in a chemistry okay, formula like HCl okay, plus HCl plus NaOH equals to NaCl plus H2O. Here HCl plus NaOH and H2O, three are what these three are lipids. NaCl is salt. So it is a heterogeneous equation, not homogeneous, because here inputs and outputs if are similar in state, then it is considered as heterogeneous. Here all inputs are homogeneous, means whatever the inputs we are taking here, all can be quantifiable, then it is considered as homogeneous. Next, there is perfect competition in the market. Already we have learned this terminology. Perfect competition means n number of firms exist in the market, n number of sellers and buyers exist in the market. There is healthy competition related to a particular product in the market, then it is considered as perfect competition. Next, there is no change in technology. If change in technology happens automatically, if technology upgrades automatically, there may be chance of variations occur in the sense of composition between the labor and money, labor and capital, so that the output may vary. So in this case, here we are assuming that there is no change in technology. Next, criticism. Cobb-Douglas production function is criticized because it shows constant returns to scale, but constant returns to scale are not actuality, because constant returns to scale is always not possible, because here by means of using a different combination of input factors, if you are using heavy level of labor at a time, there may be chance of okay reducing the overall cost incurred for such kind of labor. So here always it is not possible to use heavy amount of labor. Sometimes you can use okay lesser amount of labor, sometimes moderate level of labor, and sometimes heavy amount of money or capital to be used. Such kind of fluctuations you can find in the sense of you can in the sense of production of output. So industry is either subject to increasing returns or diminishing returns. It is not possible to get always constant returns. Industry is either subject to increasing returns or diminishing returns. These two aspects are very, very important. It means either industry is in an upward trend or downward trend. No entrepreneur will like to increase the inputs in order to have constant returns only. Constant returns automatically at that time it is not possible to increase the input factors. By means of increasing the input factors, then you can find the excessive cost. So in such a condition, it is not possible to get the equal amount of output. So his aim is to get increase the returns and not constant returns. Whenever the entrepreneur means businessman always looking towards increasing the profits by means of increasing the volume of production, by means of reduction in the cost, by means of increasing the perfection or quality in the production. These are all the general expectations by means of every investor or every entrepreneur, so that constant returns to scale is not possible at always. Next, production function is again divided into two types. One is short run production function, second one is long run production function. And short run production function is again subdivided into one variable short production function, two variables production function. One variable means only if we are going to change one input factor out of all the existing factors, and two variables means if we are going to change the two variables of out of total existing input factors. This is considered as production function types. So coming to the point of production function with two variables, this is also one of the important question from your examinations point of view. You can find a 10 marks question for your production function with two variables. So I have given the detailed information in your word file of third unit in a perfect manner about this concept, this topic, so that learn thoroughly, and you will find a assignment question for this one also. So production function with two variables, in which first of all we have to learn about iso means equal, quant means quantity. In the last class we have learned about this one. Iso means equal, quants means quantity. It means the quantities throughout a given iso quant are equal. Iso quants are also called as iso product curves. Iso product curves means by means of changing the input factors, by means of changing the input factors, if you are producing the equal amount of output or production at all times, by means of using the different compositions and combinations of the input factors, if you are producing equal amount of the output at all cases, it is considered as iso quant. Iso quantity, iso means equal, quant means quantity of production. Okay, it can be represented in the mathematical form of Q equals to integration of L comma K. L means here labor, K means capital. Okay, coming to the next slide. Production function with two variables. Two variables means here what? First of all, in first case, if we are going to produce Q quantity equals to 2 units. 2 units of, for example, 2 cars we need to manufacture. In the second case, here we are going to produce 5 cars. In the third case, here we are going to produce 9 cars, and in fourth case 12 cars, and fifth case 14 cars. Cars, we are car manufacturers. So for the purpose, here we are using capital, labor in all the cases, two variables. In first case, if we are using 1 lakh capital, then 20 labors to be used to manufacture the 2 cars. If you are increasing the capital 2 lakhs, then we can reduce the labor. So that we can using some advantageous technologies to produce the required amount of cars, that equals to 2. If you are going to increase the one input factor, automatically you can find the decrease the second input factor. You can find. Okay. Now observe horizontally. Okay. In second case, if we are going to produce, okay, Production function with two variables. Two variables means here we are going to bring the changes in the two input factors, not a single input factor. Here we are changing two input factors. Both input factors here we are changing in different condition and different cases in order to produce the required amount of the quantity. So in second case, if to produce 5 cars, we need, if 20 labors only, we need to increase the capital for 2 lakhs, because at that time we need to okay encourage them to work in double shifts, double shift, because here we are producing 5 cars rather than 2 cars. To increase the production, definitely we need to increase the labor. Okay, but here we are not increasing the labor, instead we are increasing here capital, doubling the capital. And in third case, q equals to 9. For third case, if you are still not going to increase the labor quantity, we need to increase the capital from 2 lakhs to 3 lakhs. Third one, look at the first horizontal row. And in fourth case, 420, 520, like that. So such kind of relations you can find. 520. In second case, if you are going to look at the second horizontal line. If you are going to produce only 2 quantity of cars, and we are going to initially use 2 lakhs capital and 12 labors. In the same fashion, if you are going to increase the quantity of cars from 2 to 5, and in order to keep the labor quantity in a constant manner at the rate of 12, we need to increase the capital from 2 to 3. In such a way, 2, 3, 4, 5, 6 you can increase. You have to increase. Next, third one, next fourth case, next fifth case. Look at all those cases. In such a cases, you can find the graph. You can find the graph in such a way that this is the graph where on the x-axis you are taking the labor, and on the y-axis you are taking the capital. So for each and every combination, for first case, look at the first case, q equals to 2. You can find a graph. You can find a like convex lens, convex shape, not concave, convex shape, which is sloping towards the earth, and you can find by means of decreasing the labor, by means of initially, for example, if we are using only one capital 1 lakh, labors are 20 here in the on y-axis. If you are increasing the capital, you are going to decrease the labor consistently. So graph is moving in an upward direction from left to right, right to left. In such a way, you can find the total different lines, different curves based upon the 4 cases, 5 cases. For 5 cases, you can find different graphs. Just mention units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that on labor line, like up to 20, and on y-axis take the capital from 1 to 10, that's all, 1 to 10. Then you can find the such kind of graphs which are not intersecting to each other, and which are just similar to each other but slopey towards their center, that is O. Coming to the next slide, features of isoquant. Downwards sloping from left to right, you can find that it is started at capital 20 to capital 1, capital 20 to capital 1 lakh. So downward sloping. Convex to origin, convex shape, already I said. Next, do not intersect with each other. means these curves are not intersecting each other. Next, do not touch axis. It is not possible to touch the axis because at least you can have the scope of using at least one labor. Without labor, there is no meaning of any production activity in this concept. Next, types of isoquants. Depending upon the degrees of substitutability of inputs, there are four types of isoquants. That is linear isoquants, input output isoquants, kinked isoquants, smooth isoquants. Okay, coming to the next slide, you can find the definitions and graphs for each and every type of isoquant. Linear isoquant, it represents perfect substitutability of factors of production. Perfect substitutability means one input factor can be replaced. If one is going to decrease, the another one can be increased in an effective manner in a proportional rate, then it is considered as linear isoquant. This line also downward sloping from left to right, left to right, and okay, you can find that this is perfect substitutability curve. Next, second one is input output isoquants. Input output isoquant means zero substitutability, means if one input factor is not substitutable by another input factor, then it is considered as zero substitutability. Zero substitutability means one input factor cannot be replaced by the another input factor. Then it is considered as isoquant related to the input output, zero substitutability. Next one is kinked isoquant. Kinked means what? If the factors of production show limited substitutability, means okay, somewhat extent if one factor is going to be replaced by the another input factor, then it is considered as kinked isoquants. Kinked isoquant. Next one is smooth isoquants. Smooth, continuous substitutability of factors of production means one input factor can be allowable by means of replacing the another input factor forever, consistently and continuously, then it is considered as smooth isoquants. These are all somewhat additional information from your examinations point of view, because you can find the only definition for isoquant. If you write all those things, the examiner or evaluator will be get impressed by means of your knowledge. Next, next topic is isocasts. Isocasts. What is meant for isocast? Isocast means here in the last topic, isoquant. Isoquant means by means of a different combination of input factors, if we are going to produce equal amount of output, then it is considered as isoquant. In the same fashion, if here we are going to focus on the cost of the inputs by means of keeping constant overall the cost of the total input factors, then it is considered as cost. Rather than here we are focusing isoquant, here we are focusing on keeping constant or equal amount of cost. Isocost refers to the cost curve that represents the combination of inputs that will cost the producer the same amount of money, equal amount of expenditure by means of different combination of input factors in order to produce the equal amount of production, desired level of production. If we are going to change the bringing the modifications in the input quantities to by means of keeping the consideration of constant cost, then it is considered as isocost. In other words, each isocost denotes a particular level of total cost for a given level of production. In other words, each isocost denotes a particular level of total cost for a given level of production. Means here, what, for example, if we are going to produce 10 cars, for 10 cars, here we are going to use definitely here we are going to use two input factor, that is labor and money, labor and capital. Okay, by means of different combinations, if you, for example, if you are going to use 10 labors and 1 lakh rupee, or 20 labors, 50,000, like that. Okay, definitely we need to produce equal amount of production in order to get the such kind of graph. If the given level of production changes, the total cost changes, and thus the iso cost curve moves upwards and vice versa. Okay, here in the first case, look at the IC, labor and cost. Okay, iso cost curve. Okay, here look at the curve. If the given level of the production changes, means if we are going to increase the production, we need to use more resources. To use more resources, we need to use more land, more capital, more labor, such that the graph moves from left to right continuously to when we are going to increase the production. Okay, this is nothing but iso cost curve. Next one and last topic of this session, marginal rate of technical substitution, MRTS. Already this is also very, very important from your examination point of view. Maybe you can find these three in a type of three ABC type sub questions in your 10 marks, 10 marks questions, or else you can find in the form of short questions also. The marginal rate of technical substitution refers to the rate at which one input factor is substituted with another to attain a given level of output. Okay, here if you want to produce 50 cars, for example, here the example is given. Combination A means inputs. Okay, capital is 1, labor is 20. Capital is 1, labor is 20. The initial one. Okay, there is no marginal rate of technical substitution. But at B, here you are using 2 units of in capital and 15 units of labor. Means here you are increasing 1 unit of capital and you are decreasing 5 units of labor. Note this point. So marginal rate of technical substitution is 5:1 here. Means here by to decrease 1 input factor of capital, here increase 1 input of factor of capital, we need to decrease 5 units of labor. And in the same fashion, in the second condition, in the case of combination C, to increase from 2 to 3 the capital 1 unit, here 4 units of labor should be decreased. 4:1. Next one is 4:8. Means 3 and 3 and 1. 3 and 1. 3:1. Next 2:1. Next 1:1. Means one input factor must be replaced by another input factor in order to get the desired level of output. So that how much we can substitute one input factor with another input factor with which we can improve, we can produce the equal amount of production, we can with which we cannot disturb the total quantity of production, so that we can create a meaningful substitution in order to bring out the constant level of output. This is explained by the marginal rate of substitution. Okay, so I think up to this one, today's session is closed. We will go for continue of this topic in the next class. Thank you very much.